Let's now discuss a specific example, which is image classification with CNNs. And a CNN stands for a convolutional neural network. A convolutional neural network is a special case of a deep learning neural network that has a combination of hidden layers that have some very specific kind of abilities in learning hidden features. Now, a typical convolutional neural network will consist out of a stack of two types of hidden layers. One is the convolution layer, the other one is the max polling layer. And finally, the output uses a densely connected layer to produce the final classification. Now, the interesting thing about the approach to image classification with convolutional neural networks is the fact that you can use the convolutional layers to learn some local patterns. So as you can see here, the first step that occurs in this training process is you start to learn a bunch of local patterns. And the interesting thing about the local patterns is that they are translation invariant, which actually means that once the model learns to recognize a certain type of local pattern somewhere in the image, it can also recognize it somewhere else in the image. And that makes the approach so powerful. And this is very different from other types of neural networks like the densely connected neural networks that learn global patterns. So basically, if it learns a pattern to apply it in a different place, it basically needs to retrain. And that's what makes a convolutional neural network so powerful. And then the other thing that makes a convolutional neural network very powerful is the fact that it has the capability of learning hierarchies of patterns. In this particular example that we have here, we only have like two layers, a convolutional layer and a max polling layer. But in reality, you will have multiple stacks of such combination of layers, which actually enables those local patterns to become increasingly complex. So if you think about like the image of a human, think about the first level, for example, is learning local patterns like eyes, noses, lips, ears. And then an increasingly complex pattern would be like learn face structures. And then an even more complex pattern that is still local is to learn different human face patterns. And once you have like 1,000 humans in a picture, for example, that is still a local pattern that can then be applied to every single human face that is in the picture. Now, the convolutional layer, as I said, learns local patterns by applying a special kind of mathematical operation, which is simply using a matrix that is then applied over the input data. And that particular type of matrix, in our case, in our example, is a 3x3 matrix, which is called a kernel. And there are some well-known kernels in image processing that are used for some very specific tasks, for example, like edge detection, sharpening, normalization or blur, approximation, and so forth. And then next, the max polling layer is applied to kind of downsample the data, but also to make it translation invariant. Without getting into the nitty-gritty details of how max polling layers work, what is important for you to remember here is that a max polling layer basically uses a special kind of kernel and results in a representation that is translation invariant. Actually, the max polling layer is the one that enables such a classification approach to recognize a human face, even if the picture is taken, for example, from different angles. And finally, the third step, which is actually the final step, you densely connect all outputs and you learn the classification. That is the very high-level approach that is used in most convolutional neural networks that are applied to image classification. And again, just keep in mind that this is an oversimplified representation. in real life, you have multiple stacks of convolutional and max polling layers applied with very large number of nodes in those hidden layers. And that's basically what is behind the magic of modern performance in image classification when used with convolutional neural networks.